today I will be sharing about how to calculate the cost of ownership when programming different kind of devices. So basically there are three factors of cost of ownership in a device programming house. Number one is algorithm development fee. So when you program a new device, your supplier has to give you the new algorithm supporting that device. So if your supplier charge you development fee, driver fee, then that is the cost you need to consider. Number two is the software annual license fee. So whether your programmer maker charge you the annual software license fee, and if they do, then you will need to consider that as your cost of owner as well. Number three, the socket adapter. This is the main topic I will be talking about today, because DediProg, we do not charge algorithm development fee. It's free if you have DediProg programmer or handler. DediProg does not either charge software annual license fee. So I will be talking only about socket adapter cost. When we talk about cost, we always talk about cost per device or cost per insertion. So it has no meaning if we only talk about the price itself, because the number of insertions really matters. In the programming field, typically there are two different kinds of technology used in the sockets. So number one, we call it burn-in socket. Number two, we call it Pogo Pin sockets. So burn-in sockets, it is commonly very often used in the programming field. But burn-in socket actually is not designed for the programming field. So when you hear about burn-in, that means that it is used in the burn-in industry, in the semiconductor industry. So burn-in sockets is designed to be used in the oven. So when there's new semiconductor chips, they need to test the chip performance after its aging process. So they put the chip in the burn-in socket, put it into the oven for a few hundred hours, and then take it out to see whether the chip still has the same functionality. Okay? In that case, they really do not care whether it's durable. So the often life cycle for that burn-in socket can be a few thousand to 20,000 cycles. So that is a common life cycle. And pin technology used in the burn-in socket is sometimes it's a gripper pin, sometimes a stem pin. These pins are very fragile and it's easy to break. The life cycle of burn-in socket is not only short, but also not consistent. Sometimes 5,000, sometimes 20,000. So these are causing troubles with the customers. And number two technology we talk about is a Pogo Pin sockets. Pogo Pin socket is used very commonly in the semiconductor final test process. They really care about the cost. The cost per insertion really matters. If you see that the Pogo Pin itself, you can tell that it's very strong, and the electrical conductivity is very good. The typical life cycle, it can easily reach 70 to 80,000 cycles easily. So this is Pogo Pin socket is commonly used by DediProg, particularly with the QFN and the BGA sockets. And with the BGA sockets, if it comes with many pins, like a few hundred pins, DediProg even use a PCR sockets, that is a pressure conductive rubber sockets. So either it's a PCR socket or Pogo Pin sockets. It delivers very consistent life cycle, and it's a very long life cycle. It can easily reach 70 to 80,000 cycles. So the cost per ownership, because the duration can easily reach 3 times more than the burn-in socket. So the cost per ownership of Pogo Pin socket is considerably less than the burn-in sockets. Thank you.